Okay, so in this video I wanted to run through the titration of the washing soda, calculation, sorry, for the washing soda titration. But just before I do, I just want to revise how you calculate empirical formula. Remember the steps involved. So the first step is that, remember, we calculated number of moles, and then the second step is you're trying to find the simplest whole number ratio. Okay, so in this one here, look, you've got, now this is sodium sulfate. It doesn't matter what the substance is, but it's hydrated, it's got water attached, and they're telling you that you've 1.61 grams of that, and then when they heat that, it breaks up, if you like, into 0.71 grams of the anhydrous sodium sulfate. And then by subtraction, you're going to get 0.9 grams there of water, okay? Now, how will we calculate or get the value for X, or how will you find the simplest whole number ratio there? Well, you get the number of moles. How will we get the number of moles? Using your formula, mass all over the relative molecular mass, okay? So there's the formula. Now, what's the relative molecular mass of sodium sulfate? Well, you'd add it up, and remember to always show the workings out of your relative molecular mass, and it's 142 when you do that. So the number of moles there is 0.05 moles. Water, you know the relative molecular mass of water is 18. So when you divide that, you're going to get a number of moles of 0.05. Now, which is the smaller number? Because you need to get the simplest whole number ratio now next. So the smallest number there is 0.005, so that's 1. And when you divide that by 0.05, then you're going to get 10. For that, okay, so your ratio is 1:10, all right, because you're going to need to do that in the second part of the calculation for the titration. Now, with the titration question now, I'm going to do 2014 question 1. So if you want to just have the video, stop the video and open up the question so that you can kind of follow it a bit better, perhaps. Now, your balanced equation there, look, so it's 2 in front of the HCl, 1 sodium carbonate. And then they describe in the question what they've done. So you can visualise a 250 cubic centimetre volumetric flask, and they've put 2.5 grams of the hydrated, the crystals, the washing soda crystals, and they've dissolved it in that 250 cubic centimetre flask, okay? What they've done there then is they've carried out a titration. So what are you putting into the burette? Again, you're going to put the HCl into the burette. This time, you know the concentration of the HCl. You've been told in the question that it's a 0.1 molar HCl, and they use an average of 21.6 cubic centimetres of the acid. You know the concentration of the HCl. Remember, that's going to be our starting point. What we know the molarity of is our starting point. What goes in down here then, in the conical flask, is 25, they pipetted in 25 cubic centimetres of your washing soda solution. But it's only the anhydrous sodium carbonate that will react with the HCl. So when you're calculating the concentration from the titration, it's just anhydrous sodium carbonate that we're going to be able to calculate the concentration of. Because look, that's all that's reacting with the HCl in the equation. Okay, so step 1, so same as our previous step, number of moles. Now, number of moles of what? HCl, because that's what we know the concentration of. Using your formula, V by M all over 1,000. The volume was 21.6, multiplied by 0.1 for the molarity up here, look, and then divide that by 1,000. When you do that, you're getting your number of moles at 2.16 by 10 to the minus 3 moles of HCl, okay? Now, ratio is your second step, all right? Now, the ratio is 2:1. So 2:1 is the ratio, okay? And so what you're going to have to do, well, 2 moles of HCl for every 1 mole of sodium carbonate, so you're going to half the number of moles. So you're going to need 1.08 by 10 to the minus 3 moles of the sodium carbonate, okay? That's the number of moles that will be required to neutralise the 2.16 by 10 to the minus 3 moles of HCl, okay? Third step then, remember, is that you equate the number of moles to the volume that was used, okay? So the 1.08 by 10 to the minus 3 moles of sodium carbonate, they used 25 cubic centimetres of sodium carbonate. Look, they pipetted in 25 cubic centimetres of sodium carbonate. So what's moles per litre? So divide by 25, then multiply by 1,000, and you're going to get 4.792 grams. Moles. I'm on moles first. Sorry, I skipped a step there. So when you do that, you get 0.0432 moles per litre. Now, if you don't want to divide by 25, multiply by 1,000, you can alternatively, of course, multiply by 40 to bring the 25 to a litre, to 1,000 cubic centimetres. So that's moles per litre. Now, what I was doing there was I was converting grams to grams per litre. How do you convert to grams per litre? Well, you'd multiply by the MR of sodium carbonate, which is 106, and then you're getting, that's the answer that I had there earlier, 72 grams per litre. Now I'm going to round that off to 4.58 there for the calculation for the next part of that, okay? So when you do the next part of that then, okay, so I've got now, I just want to rewrite what I have now. So carbonate, okay, that's my hydrated. So we used 2.5 grams of that originally in the 250 cubic centimetre flask. I now, 1 second now, I just want to write that there. What do I know? I know 4.58, I said, grams per litre, okay? That's 4.58 grams per litre though. This is 2.5 grams in 250 cubic centimeters. So this is a common mistake where people don't have the same volume. You know, you're not comparing like with like. If you've got grams in 250 and grams per litre, okay, so you must divide this by 4. And when you divide that by 4 there, then you're getting 1.145 grams in the 250, okay? So I have to divide this by 4. From my previous answer, I have grams per litre of sodium carbonate. But because this is in 250, I must divide this 4.58 by 4 to bring this to 250. The volume has to be the same. You must compare like with like. Similarly, if they had told you that they dissolved the washing soda in 500 cubic centimetres, then you would divide this answer by 2. Must have the same volume. Now, by subtraction, I'm going to get 1.355 grams here when I subtract this from 2.5. So that's my mass of water. And like I showed you earlier then, how are you going to get the simplest whole number ratio? Well, this is divided by the MR 106. This is divided by the MR of water, which is 18. When you do that, you're getting for number of moles, that many moles for the sodium carbonate, and the water is what? 0.75 moles for the water. How will I calculate the simplest whole number ratio? Divide by the smallest number. And that'll bring that to 1. And when you divide that by the smaller number, you're getting 6.88. And remember to round it off to the simplest whole number ratio. And then don't forget to rewrite the formula at the end by putting in the x. You know that the x is water, okay? Finally then, in that part, you were also asked, for part F, you were asked to calculate the percentage water of crystallization. So how much water? Well, look, you have 1.355 grams of water, 2.5 was your total washing soda, and then so change it into percentage then like that. Is that okay? All right, thank you.